everyone, and welcome to the next session of this day. For this session, I have a really great speaker, Eileen Weber, who is joining us from the United States. Good morning, Eileen.
Good morning.
Hi. Eileen is going to talk about changing packaging regulations. And everyone, please don't forget to ask your questions in the Q&A chat of this session. Well, Eileen, with saying that, I would like to hand over to you. Everyone, enjoy the session.
Thank you, Daria. Hello, everyone. Welcome again to allnex's Sustainability Conference and this talk on Radcure in printing and packaging space. My name is Eileen Weber, and for the past 3.5 years, I've been a global marketing manager within our Radcure group at allnex, focusing on printing and packaging. Let's start first with a little bit of packaging. Packaging is ubiquitous. We see it everywhere. It delivers our contents, it protects the contents, it provides us some convenience, and it draws us in with all of the pretty advertisement and the design on these packages. According to Smithers, the world packaging market topped $1 trillion in 2021. This is a 5% increase over the prior year of 2020. And if we look at it over the course of the next 5 years, it's projected to grow at nearly 4% year over year. And nearly 50% of packaging is being printed. This brings in the importance of coatings and inks in this space. Now, if we talk about Radcure, radiation curable, UV, EV, however you want to call it, this is a relatively small piece of the market versus other technologies like water-based or solvent-based. However, it is growing at even a faster pace than the standard. UV and EV will bring some inherent sustainability advantages. However, it's performance and processing advantages that are of particular interest. Today, I want to structure this looking at Radcure as it looks at facing or overcoming some of the challenges, but also providing solutions in relation to the 5 sustainability pillars of allnex. Of course, we could find some materials that hit each of these boxes, but I want to focus on 3 specific areas. We'll start first with safer materials. We'll talk then about energy efficiency, and finally, we'll talk about circular economy. So let's look first at safer materials. And this is important not only to make sure that we're keeping up, but that we're actually staying ahead of the regulations in play. So there certainly is an interconnectedness of the packaging industry and the corresponding coatings and inks industry. There are many regulating bodies out there that influence the market. Here I provide just a cross-section to show how it's a little bit complex and involves many things. It can be the general chemicals space, such as ECHA or OHIA, which would not only influence packaging, but all other applications. There are regional standards, there are national standards, there are those that are specific to food, there are those that are specific to printing. The important piece to note is there's really no harmonized global regulation. So therefore, it's important to always stay aware and try and figure out how to formulate in the most complete way possible. But we are also not looking at only at what is there today, but also what we anticipate it to be in the future, because regulations are not a static entity. So I want to use the Nestle guidance as an example here. So why the Nestle guidance? What is it? The Nestle guidance is the guidance for all Nestle packaging and the printing inks for food packaging. This is one where it has it draws in from other references. So first and foremost, we look at it in relation to the reference of the Swiss ordinance, in which case it's drawing on to say that any substances not listed in the Swiss ordinance may not be used in Nestle formulations. The Swiss ordinance then has a Part A list where chemicals have been evaluated and have a specific migration limit. There is then a Part B where chemicals have not been evaluated, but are allowed with a default migration limit of 10 part per billion. So Nestle has revised this or their guidance several times, with the most recent being of this year. It's also important to note that the Swiss ordinance is also under review and could be also changing in the near future. So these are important things to show the interconnectedness of these regulations. Further to note, chemicals can be listed on the Swiss ordinance, but they can be further excluded from Nestle formulations. Nestle includes other definitions, such as their suitability list, their exclusion list, where components may be allowed by the Swiss ordinance or even by UPIA, another regulatory body, but they are forbidden for Nestle formulations due to quality or safety concerns. And then there's the minimization list, where components may be allowed by the Swiss ordinance, but would have further special requirements that apply for Nestle formulations. It's the exclusion list and the minimization list that I would like to go into a little bit more detail. So let's look first at the general exclusions. This here is an extract from the Nestle guidance and a list of their general exclusions. I'm highlighting here BPA, also known as bisphenol A. The exclusion relates to not only BPA, but also materials manufactured from or incorporating BPA in the reacted form as part of the chemical structure. Over the years, we've heard a lot about BPA and how it has been found in some of the contents of packaging. BPA is a known endocrine disruptor, and although it's not outlawed very much across countries, it has a lot of negative consumer awareness, and this has brought to spotlight by Nestle and other governing bodies to eliminate it from its formulations or its contents. Next, I want to talk a little bit specifically to the Nestle guidance for UV systems. So this would be around acrylates. Nestle includes an exclude list, and you can see here a list of some of those materials that are forbidden by Nestle. These are materials, as noted, are on the Swiss ordinance, but should not be used in Nestle formulations, either in their original form or brought in as impurities into the system. Furthermore, Nestle has a minimized list, and I include that here as well. I highlight, though, tmpta, because tmpta is a product that is used very commonly in a lot of UV formulations. It provides good performance, good cure speed, and also it comes at a very competitive cost. It has been part of the minimized list of Nestle for quite some time, and there's been ways to avoid this or to find alternatives, including alkoxylated versions of this, which would minimize the amount of tmpta, but would still consider maybe small residual amounts. Of course, tmpta is a product over the last 25 to 30 years that's been the subject of studies and has shown some negative results. So this is where I show the need to stay aware of the changes within the regulatory space as you're considering your formulation. Let's first look at some of these changes that are coming into play. The first one is brought about by ECHA, the European Chemical Agency, and as noted, this is not packaging specific, but includes all applications and use of the materials. Earlier this year, ECHA published their new ATP, which notes the reclassification of tmpta as a carcinogen class 2 material. The final implementation date of this will be next year in November. So what does this mean? So within the GSH labeling, any product that contains tmpta at above 1% would carry a new label as a carcinogen category 2. Now 1% is the threshold. So if tmpta is less than 1%, but still above 0.1%, it wouldn't change the final labeling, but it would still be included on the SDS and the related hazard would be noted. So therefore, to avoid tmpta at all on the SDS, it would have to be below 0.1%. So now let's look at the interconnectedness. So this is stemming from the same studies of the past. Now let's bring in OHIA. OHIA is the California Office of Environmental Health Hazard Assessment. OHIA is responsible for the California Prop 65 list, and materials can be added to the list in a variety of ways. In this particular instance, tmpta has been added to the Prop 65 list under the Labor Code. This incorporates chemicals that have been identified by the WHO's International Agency for Research on Cancer, also known as IARC, as causing cancer in humans or in lab animals. So what's the difference of these? Well, with Prop 65, it is actually de minimis, or zero, meaning that there can be not even residual tmpta in the product in order to avoid the labeling. However, also along with Prop 65, they do have what is known as safe harbor levels. That is, by law, if exposures are low enough where they don't pose any significant risk, then the testing can be done and the warning label can be removed. In this case, though, for tmpta, it's relatively new and there has not been an established safe harbor level. This adds a little bit more complexity for those who are global suppliers and may be providing global global products both into Europe as well as into the US that would end up in California. So how then is allnex looking to address these? Well, let's go back a little bit to the topic of BPA. As noted, there's rising consumer awareness and negative views and regulations on products that contain BPA due to its health concerns as an endocrine disruptor. In the world of UV formulations, epoxy acrylates have long been used because they have high reactivity, they can produce coatings and inks with very high gloss, good chemical resistance, and they're relatively inexpensive. However, BPA is contained in all epoxy acrylates. BPA can also be in some polyester acrylates, as well as some diluted polyesters. One set of diluted polyesters where it's common are chlorinated polyesters. Chlorinated polyesters are great for providing adhesion and other properties, but they're often built around BPA containing materials. If a formulator is looking to replace BPA in their systems, often this is difficult without doing a lot of reformulation in order to get those same properties. However, allnex now has brought to the market several solutions that are BPA free, and some of these can be drop-in replacement resins. So the first I want to mention is Epicryl 876. This is a BPA-free alternative to a standard diacrylate bis-A type epoxy. It provides very similar cure response as well as the properties and can be used in the system as a direct replacement. Also, related to the chlorinated polyesters, we have two products that are BPA-free as well as tmpta-free, these being Epicryl 417 and 418. Now, what about for tmpta? This one's a little bit more complex because it can depend on what region of the world you're formulating for. And as such, are you looking just to minimize it or are you looking to eliminate it? In the instance of trying to minimize tmpta, we have two products that we can offer. The first being Epicryl 853, which is a trifunctional acrylate that can be used for diluting purposes. We also have Epicryl 892, which is a tetrafunctional polyester acrylate of good low viscosity. In the case of trying to completely eliminate tmpta, we can offer two solutions, the first being Epicryl 50, which is tetrafunctional, as well as OTA 480, which is a trifunctional material. The approach to replacing TPA can be varied by geography, it can be by end use, by application method, or even by specific formulation method. So these here are only a few examples of the products we have in our portfolio to highlight. Certainly, if you have this on your radar as a project, please feel free to reach out to us and we could discuss your specific needs and how we can help you find good solutions in replacing or minimizing tmpta. Before we move away from safer materials, I want to touch on one more part of allnex's portfolio. As mentioned, in the world of food packaging, low migration as well as materials with low extractables and low odor are very important. We have a full product line that meets these needs. Our low migration materials as well as our LEO materials that are low extractable and low odor have an adapted raw material approval process where we look to minimize the amount of impurities in the incoming material. Then, within the manufacturing process, we have extended quality control, we look at traceability at every stage, and we put strict guidelines and specifications around impurities to minimize these as much as possible. These products are designed for use in food packaging and could be a great solution for your product needs. Now let's move on to the next pillar, which is energy efficiency. As I mentioned earlier, UV curing has some inherent sustainability advantages. However, 30 to 40 years ago, when UV was coming onto the scene, That wasn't really the driving factor of the advantages that it brought. Because UV uses light instead of ovens, because it's a very quick curing process, this allowed for advantages such as faster line speeds, smaller footprints. Because it was an instantaneous cure, it also eliminated or reduced the amount of wait time before you could package materials and ship them off to the next step. So this increased productivity by reducing the work in process stage. Also, what is inherent to UV formulations is their low and no VOC capabilities. So what's next around energy efficiency? Well, next on the list is the rise of UV LED curing. So what makes LED curing different? Well, first, by comparison to standard mercury vapor type of lamps, LED curing contains no mercury and no ozone. They are also a very wavelength specific, a very compact material or compact design, and it's scalable for large to small sizes. Another advantage of LED cure is the fact that it's very consistent curing over a long period of time. That is, instead of what as you would see with a standard mercury system, that it would decline from the minute you turn on the lamp at the beginning, and over time you would start to see a degradation of the output. However, with LED systems, that intensity remains high and constant over a long period of time and can last much longer. Furthermore, the difference of LED versus standard mercury is that they're wavelength specific and not emitting any of the extraneous IR. So therefore, it's going to be an even lower operating temperature and more suitable for heat sensitive substrates. This provides even further reduced energy consumption. So LED can be a good solution to significantly lower the carbon footprint within printing and packaging. LED is growing and developing every day. And the importance is that the lamp technology and the chemistry go hand in hand to make it successful. What's important with LED is because it's wavelength specific, you must choose photoinitiators that will absorb and react at these specific wavelengths. Additionally, it is very common to use synergist to help boost the cure. Most commonly, aminobenzoates, things like EHA or EDB, are commonly used as LED boosters. These materials, because they're not acrylated, can migrate in the system. Further, their labeling is such that it's not very favorable for use, especially in food packaging. Allnex has designed a series of LED boosters that are alternatives to aminobenzoates, where they have more favorable labeling and a lower migration profile. Here we list 3 specific products, each designed for a little bit different applications. The LED03 is great for clear coatings with low yellowing and low viscosity, light colored inks, like those for inkjet or flexo. The LED04 is one of our newer developments and designed more specifically for offset printing, where ink water balance is important, as well as maintaining the good pigment stability over time. And then LED05 further maintains that good pigment storage stability, but is lower viscosity, making it a little bit more conducive for printing by flexo applications. Let's touch on the final piece, that of a circular economy. One of the fundamental ambitions of sustainability is the shift from a linear economy to that of a circular economy. The linear economy, the cradle to grave model, is a take, make, and dispose. However, in a circular economy, it is cradle to cradle in terms of make, use, and recycle, with the intent to significantly lower the waste in the environment today. Although there are many agencies out there that are responding to the public call to action, I want to highlight the Ellen MacArthur Foundation because over 500 organizations have shared in their vision for a new plastics economy initiative. In this, I want to focus specifically on the key points that of the goal that all plastic is 100% reusable, recyclable, or compostable. And it's not only that it is able to be, but that it is actually done so in practice. If we look at specifically recycling, this is an important area where Allnex is looking to provide solutions. So one of the important aspects of recycling is to ensure that the plastic is it's clean and pure when it goes into the recycling stream. So think about the case of bottles with labels or without labels that are printed. And it is important to ensure that as it goes through the system, you can easily remove the ink as it reaches the wash step that is done with a caustic solution in the process. For this specific application, allnex has developed our Evacryl 577, which is a polyester acrylate that is suitable for alkali stripping. It can be used as a primer such that it accepts the ink during the process, and at the end of life, it easily helps to remove the ink when it goes into the recycling process and the caustic wash. This has been tested in accordance with the guidelines of the Association of Plastic Recyclers and can provide a solution to further improve our goals to move towards sustainability. This brings us to the end. So in summary today, we've talked about safer materials, energy efficiency, and a circular economy. The challenges that we see here, as well as some of the solutions that allnex can provide when looking at these areas. I highlighted only a few here. We have certainly more products in our portfolio that could be used in similar applications, and would love to talk to you more if you have challenges that you need to overcome and if allnex can help to provide such solutions. I thank you for your time. I hope you enjoyed today's presentations and now open it up for questions.
Oh, I apologize, everyone. I believe I was muted, so I will repeat what I just said. Thank you, everyone, thank you, Eileen, for presenting. Thank you, everyone, for asking and your questions. And that brings us to the Q&A part of the session. So, Eileen, first questions for you. Will tmpta be considered as carcinogen, or could it be considered as an alternative in certain cases for replacement of tmpta?
Sure, that's an excellent question. I think most people recognize that ethoxylated tmpta has often been used in a lot of printing and packaging because it provides a lot of really good properties while minimizing the amount of tmpta. Of course, ethoxylated tmpta is built out of tmpta or TMP containing products. So therefore, there would theoretically always be some residual. If we're looking at the relabeling by ECHA, the reclassification, as long as it is less than 1%, it would not require the label to be added. So therefore, it could be considered in such applications to comply with that. However, if we're looking at California's Proposition 65, which is a de minimis, in that case, it's going to be a little bit more difficult because there would still be some residual present.
Thank you, Eileen, for answering this one. The next question is on BPA replacements. Are these substitutes other bisphenols, or is it a completely different core structure?
Could you repeat the question? I'm sorry.
Yes, of course, I can do that. Another question on the BPA replacements.
Yes.
Are these replacements considered as other bisphenols, or it's a completely different structure, or do they have completely different structure?
Okay, understood. Thank you. Yes, in terms of our approach to this, we are looking to completely stay away from bisphenol products and looking at other ways to create alternatives for them, both in terms of the alternative to a standard epoxy diacrylate that I mentioned, as well as those within our chlorinated polyester, diluted chlorinated polyester line.
Thank you, Eileen, for answering this one. And the next one, with LED cure, do you need to use specific photo initiators to improve LED cure, or just formulate with amino synergists, or just LED boosters?
Sure. In the case of LED cure, it does require a photo initiator, and you would want to choose that photo initiator based on the type of lamp output that you're using. Most commonly, I mentioned the 395 or a 365 nanometer type. So you would need the photo initiator, and then the use of the booster is going to help that to react a little bit faster.
Thank you, Eileen. Another one. Under the new regulatory changes for tmpta, if tmpta is not listed on the safety datasheet, does that mean also that it doesn't require a PROP 65 warning label?
Well, that would be up for interpretation, I think, by the the regulatory departments. Our interpretation of this would be that if there is any amount of material in there, regardless of if it's included on the SDS or not, then it would require the warning label to be added.
Understood. Thank you so much. Hello there. Hello. Can LED cured coatings be of any color? Our attendees, or yes, four of them think that some colors would block the wavelength.
Sure, yes. When you're formulating with LED or UV in general, it's always a little bit of a challenge with the various colors, because what gives color also may be blocking some of the light that's used for cure. However, by choosing photo initiators correctly, by looking at the pigment load, by using boosters, for the most part, these colors, these more difficult colors, could be achieved with an LED cure system.
Thank you for answering this question too. Next one, do you have anything to replace aliphatic urethane acrylate resin?
Anything to replace an aliphatic urethane acrylate
Mhm.
resin? Yes, I'm not sure the specifics of the formulation or the application or necessary properties. We do have a variety of products in our portfolio, and certainly would ask that you reach out to us and we could discuss your specific application in a little bit more detail to find an adequate solution for you to replace that.
Thank you, Eileen. The next one, when you react in the tmpta after UV cure, is the final coating also regulated for tmpta content?
No, that's a really good question, and I think that is an area that is under discussion by different people and different organizations. I mean, theoretically, the way that the warning label works is if there is unreacted or residual material, then it would require a label. However, I think the question is to what degree is the system reacted? This is going to be dependent on that application and processing step, and so I think there is a lot of discussion as to what remains there, and then does it require a label? To really know, a certain level of testing would have to be done.
Thank you, Eileen. The next question. Well, our attendees, thank you for would like to express thank you for your presentation. And they ask a question, are these sustainable abacryl materials are safe for use in food contact after curing?
When we look at our materials and we talk about food contact, we're specifically looking at indirect food contact. It is not our focus to look at these for any kind of direct food contact applications.
Thank you for taking that one. Regarding the question regarding de-inking primer, for which substrates it is used? Only polyester or also polyolefins like PE or PP?
Sure. In our design of the product, we focus specifically on PET as well as polypropylene. So we have solutions for both of those, if they would like to discuss with us further.
Thank you for taking that too. Liquid resins and additives has also a very wide range of products designed for energy saving. Are they also well included into all marketing brochures and promotion tools?
The products from our liquid resins and additives group.
Yeah.
Well, I would have to say that I may not know all of the brochures that are in reference to answer that question very well.
I believe they do, but we can answer that question after the end of this session. Can back to you with the
Very
answer.
good.
Thank you for asking this. Next one, for the de-inking primer solution, does it meet the regulatory criteria discussed in the earlier part of your presentation?
Yes, it does. That in terms of safer materials, it is in compliance with what was discussed. It would comply with Swiss and Nestle especially, which I think might be what the question is asking.
And we have, thank you, Eileen, and we have the last question for today. And I would like to take it if you don't mind. Actually, it's a question
Please
for
go
me.
on.
Will it be possible to download your presentation? Yeah. Indeed, it's a good question. Yes, it is possible to download all the presentations that you are going to see today, tomorrow, and the day after tomorrow. We will try to upload the first block of the presentations today that you're going to see today by the end of the day today. But anyhow, everything as well as presentation and recordings will be available fully on the platform on 17th of October. So yeah. You need to wait a little bit. It's Monday next week. Yeah, and with saying that, I would like to say thank you, Eileen, for presenting today. Thank you, everyone, for your questions. And I would like to invite you to the next session of this day that is going to start in 14 minutes. See you there. Thank you, Eileen.